Assalamualaikum and very good evening to all of you. Welcome back to our class. Today I will discuss about the work-based project where I will focus on the loading on slab and the beam. Okay, let me present my slide first. Okay, can you see my slide? Okay, here is the key plan. Okay, structural sketch of the key plan, which contain the position of column and position of beam, and as well as the different level of slab. Okay. However, I did some adjustment to this key plan. If you still can remember, in our last class, I proposed the balcony to be located here. Okay, to be located here, the balcony here. And however, I want to change to this. Okay, sorry, the balcony is here. Okay, in the first floor plan. Okay, which is the open space balcony. Okay, for flat roof. However, I changed to prayer room, and I wanted the balcony to be here. Okay, and this is the roof plan. Okay, this is the detail. Okay, class. This one is the detail. Okay, about the structural layout. Okay, the guest room still at the uh, ground floor. Okay, and this is the roof. Okay, I hope you can understand this is the center of the roof. This is the center of this one is the center of the roof, and this is the how where the rainwater will fall. Okay, you must can imagine. Okay, if we look from the front, okay, the house shall be look like this one. Okay, this is the roof. Then this is another one. Okay, and the back here is the another roof. Okay, and then we have balcony. Okay, the roof is okay, and this is the wall. Okay, here. Okay, this is the okay. Let's say this one. Okay, do we have maybe we have window here and also here. Also here, okay, for the staircase, why not we put a window, and then also here, and as well as here. However, here we have a balcony, okay, balcony here. So we have around here. So this one, we have the parapet wall. So here is our balcony. I want the balcony there. So this is the maybe awning for the balcony at the back. So this is the porch, and then it will extend here. Okay, this is for the open space. Okay, open space balcony. So the balcony, this is the 1.2 meter brick wall. Okay, instead of steel, I want to use the brick wall here. And then if we look from this side, it will look like this one. Okay, this is the roof. Okay, and then this is the main roof. Okay, this is the balcony. We have balcony here. For this one, this balcony is here. So this is okay. We have a balcony for the main master bedroom. Is the balcony. Okay, at the bottom is the guest room. This is maybe sliding door, and then this is the roof, pitch roof, the pitch roof, and then this is the another room. Okay, and then this is the open space balcony. Okay, and at the bottom is the porch for a car. Okay, so I hope you can understand my drawing. Sorry, because I still don't have time to provide the elevation view. Okay, so I hope you can imagine this is the pitch roof, where this is for the study room. Let's say the study room. So this one is the study room. but at the top is no. This is the roof. Okay, for this one, the pitch roof. Okay, so I convert the key plan to be like this one. Okay, I make it clearer. Okay, I use Microsoft Words. Okay, only Microsoft Words to do this. Okay, of course from this key plan. Okay, from this key plan, I do the screenshot. Okay, I do the screenshot and then I paste in the uh, Microsoft Words, and this is okay what I did. Okay, the red color represent the position of column. Sorry, I still not label it. Okay, and then what I want you to do is like this one. Okay, you can do by AutoCAD and you can do by Microsoft Words first. Okay, so I hope you can see clearly. Okay, this one. Okay, so of course, still missing here is the void. Okay, the void is here. Let's say this is the void. Okay, this one is showing you the void because the roof will be uh, constructed by using the trusses, steel trusses. Okay, and then also the void here you must label as void at the roof plan. Okay, this here is the void. Later you must do in your drawing. This is void. Okay, here I prepare two slab panels for water tank. Water tank maybe is here is for water tank, and this one is for the maintenance purpose. Okay, this is the void. Okay, so this is the roof plan. So this one, I want you to do is estimate the size of the beam. You can label if you can see this one clearly. Okay, I label at the ground floor plan. I label by number. Okay, by number. So the horizontal beam, the number is odd number. This is practice by a consultant. Maybe odd or even number. Okay, up to you. Okay, so this one, let's say this is GB1. GB1, the size is 200 times 500. Can you see it clearly in your screen? I hope you can see. Okay, can you see the GB1? How many span of GB1? I asked you one question. How many span that we have?
One.
One span?
Three.
Okay, how okay, good. Three span. How many span and how many support?
Four support.
Okay, good. Four support. So this is span number 1 from A to B. Span number 2 is from B to C. Span number 3 is from C to D. And then this is the support. Okay, this column, this column, this column, and this column. So we have 4 support. Okay, and so this is the primary beam because it is directly supported by columns. Okay, so you can see, if you can see this one, okay, for the beam, okay, horizontal beam. Okay, let's say this is a horizontal beam. This one horizontal. Okay, on plan. Okay, what is the size? Okay, the size is 200 times 500. How I got the 200 is okay. The sizing of beam is normally 150, 175. The width, okay, then 200, 225, 250. Okay, the increment is by plus minus of 20 mm. This is the increment, or 1 inch. Okay, 1 inch. Okay, this is the increment. Okay, never design your beam 158.227 mm. Okay, mm. Okay, in your calculation, maybe this one is okay. It passed the calculation, good. But how can you imagine how the laborers or the construction workers on site want to set up for this width? Okay, they say this one. Okay, what's the width? The width is equal to this one, 158.227. How the contractor will set up for this one? Okay, maybe if you use a steel or fabricated on site fabricated inside the factory, maybe we can set up, but the factory also use this practice, okay, which is the increment of 25 mm. So the 500 I got is from the longest one, 6,500. 6,500 divide by 10 to 15. Let's say I divide by 15, so 6,500 I divide by 15 equal to, okay, can you use your calculator for me? What is the answer? 433, right? 433.33. So I make it round up to 500. I can go for 550 for, but I think because of the spare and the loading, 500 is better. Or maybe it will fail, but it's okay. We just use the preliminary sizing to make it safe. You just divide by 10, so it will be 650. But I want to try by 15 first. Maybe it will fail based on our calculation later, so we can revise later. So what I want to you to see is, okay, for this beam, GB number 1 is here. Okay, GB number, okay, I better use, okay, this is GB number 1, and then GB number 3. This is how to label, label and numbering. And then after 3 is GB number 5. I label the primary beam first. Okay, 5 and then 7. Okay, stop, 7. And then after 7 is 9 here, GB9, still 4 horizontal beam. Okay, the number is odd. Okay, let's say 1, 3, 5, 7, 9, blah, blah, blah. And then the size for the secondary beam, you can reduce the size. Okay. And this one, GB after 9 is 11. Okay, I make it smaller, 150 times 300 only. And then until GB 13. Okay, the same goes to the upper floor. This one, okay, can you see? 1 and then do some adjustment. 1, 3, 5, 7, 9, 11, 13, and then because we have additional here at the balcony part, so make it 15. Okay, and then you go to the ground floor beam, which is vertical on plan here. Okay, I call it as vertical. So we start by GB number 2. Okay, you can do the sizing, similar size is okay. And then up to 2 is 4, 2, 4, 6, 8, and 10. Okay, why we do this kind of numbering? Because it will be easier to refer on site. Okay, if you have a problem on site, maybe for this beam, maybe you check that the reinforcement is not enough, so you refer what is the beam number, is GB number 8, so you can refer the beam detail so to check what is the exact reinforcement. Okay, the similars go to the goes to the first floor beam, first floor plan. Okay, this one. So I hope you can see. And also this is for the roof beam. Okay, we name it as RB for roof beam. Okay, we do the numbering and we do the sizing. Okay, and also we go to the column to the, sorry, we go to the slab. Okay, okay, I show you the different level of slab because of drop. Okay, so I use different color. I wouldn't want to confuse during modeling later, so I use different color. Okay, and then we must differentiate the slab. Okay, we use this symbol, okay, to differentiate either the slab is one way or the two-way slab. Okay, I believe you know. Okay, okay. Can I ask you, what is the difference between one way and two-way slab? What is the situation?
The reinforcement.
The reinforcement, okay. And okay, how to detect either the slab is one way or two way?
LY over LX.
Okay, what is LY and what is LX?
LY pada panjang, LX pendek.
Okay, okay, it's okay. You can use bahasa Melayu, okay? It's okay. Our PM Ismail Sabri Yaakob also use bahasa Melayu. Okay, I also plan to use bahasa Melayu, but we have international students, so I still use English for formal class. Okay, actually I also want to use bahasa Melayu. Okay, if you want to ask in bahasa Melayu, also you can ask in bahasa Melayu. It's okay. Okay, so this is the okay. LY is the longest. Betul? LY is the longest side of the slab, and LX is the shorter. Okay, this one. So LY for this slab, let's say LY is equal to 6,500 and LX is 2,000. So of course it will be more than 2.0. Can I get the exact answer?
3.25.
Okay, 3.25. Thank you. So 3.25. So the loading from this slab will go to which beam? GB1, GB9, or GB4 and GB2?
GB1, GB9.
Yes, that's good. It will fall on the longest side. Okay, longest beam. Okay, this attached to it. This is the slab, and this we have 1, 2, 3, and 4. 4 beams attached to this. To support the slab. So it will go to the longest. So that's why you can see the half arrow there. Okay, make sure you use the right label. Okay, this one, this is showing that the forces is go to the beam and to this beam. Okay. Okay. How about this one? This shall be one way or two way?
Two-way.
Two way. 2.0 still one way or two way? So this one, okay.
Two ways.
Two way. One way is greater than, okay, if equal to 2.0 is still two way. Okay, one way is if the greater. Okay, so here is the two way. So here also must be two way slab. Okay, okay. Thank you very much. Okay, so the loading, I believe you already familiar with the loadings on the beams. Okay, how many types of loading that we consider in our syllabus? How many types of loading? The permanent and the another one is
Permanent and variable.
okay, good. The permanent load is what is the symbol of permanent load?
GK.
Okay, good. GK. And the variable load is
QK.
okay, QK. Okay, what is the example of permanent load?
Self weight of slab.
Okay, self weight of slab or beam. Okay, and then another one. The permanent load based on your experience.
Finishes.
Wall.
Yes, finishing including the tiles. Okay. Okay, and then ada jawapan tadi?
Wall.
Oh, okay, wall, either brick or partition. Okay, or gypsum board partition. Okay, good. And also, how about the roof trusses? You think roof trusses or roof material is permanent or variable? Roof trusses at the top. Okay, for roof beam. Roof beam will support the roof trusses. So the roof trusses is permanent load or the variable load. If you talk to the okay, if you join the consultant later, they are familiar with BS. Okay, in BS, permanent load is known as what? This is not permanent load, this is permanent action actually. Okay, the word load in Eurocode is known as action. Variable action and permanent action. Okay, in BS, okay, kalau you jumpa orang lama dekat site, okay, atau dekat consultant, you jumpa orang lama atau otai, apa yang dia cakap? Permanent load tu apa? Okay, you must know this one. They are not using permanent and variable, but they're using the dead load and the live load. Okay, that's the terminology. Okay, you must familiar. Okay, so how about the roof trusses? Roof trusses is permanent or variable? Can somebody answer? Roof trusses?
Permanent tak betul?
Okay, good. Okay,
Permanent.
okay, good. Roof trusses and roof sheet, roof sheet material. Okay. And then how about the variable action? You know the variable action? Can somebody give me example of variable action?
People moving up and down the room.
Okay,
Foot traffic.
people inside. Okay, foot traffic.
Uh,
Any others?
If there are any appliances or if it's a storeroom, so that also becomes live load because there is
Okay.
force acting.
Mhm.
Uh,
Maybe we can say as goods or let's say furniture. How about furniture?
Yes, furniture.
Furniture is live load or permanent load?
Like
Live.
Because
live load.
as live load, okay, because we can move it. Okay, we can move the furniture or we can adjust the arrangement. Okay, and how about water tank? Water tank here. Water tank we consider as live load or let's say okay water tank. Live
Water
load
tank
or dead load?
live load because the
That
live load because the volume in the water tank is always changing.
Changing. Okay. One answer and then another answer, another reason. Saya dengar ada yang cakap dead load tadi. Kenapa jadi dead load?
because we don't move the water tank.
Sebab air kat dalam tank tu selalu akan tambah juga.
Okay, good. We the first reason is we don't move the water tank. Okay, thank you very much to those who answer the live load. Okay, it's okay. You have your own judgment. Okay, but the water tank we don't move. Okay, and then the water always refill automatically, right? So this is let's say your water tank. Okay, and then this is your let's say this is your slab to cover for water tank. Okay, then this is the beam. Okay. The water usually, okay, as I consult to professional engineer, okay, in industry. Usually, when they want to use to consider water tank, they always consider as the dead load or permanent load because let's say this is the level of water, okay, and then when we use the water will go down, okay, the level will go down. Okay, the means the loading is reduced. But however, we must consider that there will be automatic pump here. Okay, that will fill the tank automatically because we have the valve here. Okay, when once the valve is once the water is close to certain level, then the valve is automatically closed. So we consider as the dead load. Okay, thank you. Okay, so this one, okay, I want you to know that we have the load on slab and load on beam. Okay, load on beam comes from where? Where is the source of loads from beam? Okay, let's say the one. Okay, I hope class you can do some writing, okay, and do some sketches, okay, write your notes. Okay, load on beam. What is the source? Load on beam. Usually, what is the source? Load on beam.
Wall.
Okay, wall.
From the
Okay,
roof.
from the first is wall. Okay, wall, and then second
Column.
column on beam. Okay, also sometimes we have column on beam. Okay, let's say we have beam here, and then we have column on beam, and then is another column. Okay, maybe at the this one is a lobby of a hotel. Let's say they want a very huge space, so they put the column on the beam. We call this one as transfer beam, and the point load here will be very huge, very heavy. So this beam will be very big. Okay, usually. Okay. Also, there's also column, okay, as a transfer beam. Okay, thank you. And then another source of load that will act on beam.
Slab load.
Okay, slab. Good, slab. And then the fourth one.
Roof trusses, Doctor.
Okay, good. Roof
From the
trusses.
roof.
Roof trusses from the roof. Okay, let's say you can let's say this one. Okay. Okay, here for this beam FB10. FB10 is by roof trusses. Let's say if I cut this section here, so FB10 here, let's say this one. Okay, this is the FB10 is located here. So this is another beam here. Is FB8. Okay, this is FB8. This is FB10. So they will install propose the roof trusses to be here. Okay. Okay, they will support here. This is let's say this one. This is the roof trusses. Okay. So the roof trusses here. This is the support. It will supported by FB10 and FB8. Okay. Okay. Another source. Roof trusses, wall, column, slab. How about the safe weight? Okay, safe weight of the beam also the source, and also we have uh uh from another from secondary beam. Okay, it will become the point load there. Okay, like let's say this one. Okay, this one. This is the FB12 will become a point load to the FB1 later, because the FB12 is supported by FB1 and FB3. Do you agree with me?
Yes, Doctor.
Okay, thank you. So, okay, this is the source of load on beam. Okay, that you have to calculate. Okay, so this is a very rare. Okay, quite rare. Okay, for very special project. Okay, and then what is the source of the load on slab? What is the source? What is the source? Anybody?
Live load furnitures.
Okay, live load furnitures. Okay, let's say furnitures. Live load lah ya, senang cerita live load. And then another one.
Self weight.
Okay, safe weight. Thank you. Then
Water tank.
water tank, okay. And then
Wall masonry.
okay, masonry wall, okay. Masonry wall, okay, maybe, but this is okay, let's say we have special case. Let's say we have wall here. Okay, let's say we have wall here. Let's say I want to divide our, this is actually our store, okay? This is actually the store, but I want to divide the store to be a half store and half space for to do laundry, where I will put the washing machine, and I want to divide. Maybe this is I want to divide. I want to do the brick wall, okay? But I don't want to provide beam, so the brick wall here is known as line load on slab. Okay, so maybe there will be special reinforcement to be installed here, because we on the slab is the slab, and we have the line load. Okay, line load. Okay, just like a point load, but continuously. Okay, any other loading, any other source?
Finishing.
Finishing. Okay, good. Thank you. Finishing. Okay. And what is another one? Let's say number 6. Load on the slab. How about the mechanical and electrical equipment? Okay, let's say fan, apa lamp, wiring, let's say aircon. Okay, and also we have at the roof, at the rooftop here, flat roof, we have the apa waterproofing. Okay, we have waterproofing, and then what else? Under the slab, what we have usually under the slab? If you're in the house now, can you look up to to the upper to the upper floor? What you have before your roof or before your slab? If you are in the second story house, let's say you are in the this is okay, second story house. Okay. Let's say you are sitting here, you are sitting here. Please look at the up. What you see? What will you see?
Ceiling ada.
Yes, good. Will see the shilling. The shilling here. Okay, the shilling here will be attached on the slab, upper slab. Okay, so we have the shilling. Okay. Okay, so this is also except number 1. Okay, except number 1, all these are the can be considered as the permanent load. Okay, so like this one. Okay, I show you this slide. This actions on the beam. Okay. Okay, this one. I believe you know. Okay. Usually I use for every the UDL from the brick wall is equal to 3.0 kilonewton per meter height for every 1 meter run. Okay, what does it mean? Okay, this is the loading including the material of brick wall, as well as the plaster, and then the painting. Okay, let's say we have this is the pandangan sisi kanan of a school building, 4-story school building. Okay, so let's say we have the story okay, the loading is equal to, for every 1 meter height is equal to 3.0 kilonewton. Okay, let's say this means that this one, okay, for every 1 meter, this one, 1 meter and 1 meter height and 1 meter length, the loading here is equal to 3.0 kilonewton per meter. Okay. So let's say if we have this one, okay, for let's say for beam number 4, let's say that the height is equal to 1.2 meter. So what is the loading from the brick wall? Okay, like GK is equal to the height times what? Times the load. Okay, the load from brick wall is 3.0. Okay, I use 3.0. Actually, you can reduce to 2.6 or 2.4. Okay, depend on the materials. Okay, but I usually use 3.0 as a conservative approach. So what is the height now for beam number 5 at the top floor? The height is here from, okay, good. Okay, the height is from the top of the beam up to the top of the wall. So 1.2 times 3.0. So what is the value of the load from brick wall?
3.6.
Okay, good. 3.6 kilonewton per meter. Okay, so now you have the loading of 3.6 kilonewton per meter. Okay, very simple. So how about beam number 2? Let's say beam number 2 for span number 1. Okay, let's say this is quite challenging. Okay, I mean you have to make it berhati-hati lah, be careful. So let's say from here to here, the height is 3.3 meter. Okay, and then the beam size is 200 times 600. Okay, so what is the clear height here? So the loading from the brick wall. Okay, let's say for beam number 2 is equal to clear height times 3.0. What is the clear height? Is equal to 3.3 minus 0.6 is here. 0.6 is 600 mm minus 0.6. Okay, you must minus this depth of the beam times 3.0. So what is the load from the brick wall for beam number 2?
8.1.
8.1. Okay, good. Kilonewton per meter. Okay, but this is for this span. For span, let's say this is span number 1 and span number 2. For span number 2, the loading is here. Okay, 8.1 kilonewton per meter. Let's say how about span number 1? Let's say the height is similar to the upper, which is 1.2 meter. So here the loading is smaller, which is 3.6 kilonewton per meter. This is important. You must know this one because you must know the exact value to install in to assign on your beam during using the Tekla software later, and also from your calculation, for manual calculations. Okay. Okay, this is load on slab, action on slab. Okay, variable actions. I believe you know how to select the value of variable actions from the table. It's okay. We'll do it together later. Okay, the source is, let's say this is a ceramic tiles. Okay, for finishing. Okay, we consider usually based on my practice and based on my reference books, as considered as 1 kilonewton per meter square. Okay, okay, sorry. So this one, okay, let's say this is the red color is the beam. Red color is the beam, and then the lighter blue is the ceramic tiles, which is on the slab. Okay, and at the flat roof, we use the waterproofing, as I mentioned before, for the rooftop. Okay. And then let's say we have here, we have shielding. As I mentioned before, shielding is attached on the, okay, we use the steel. We install the steel and then the shielding is rest on the steel, and then steel is connected to the slab, upper floor slab, I mean. Okay, suspended shielding is around 0.15 kilonewton per meter square. So like this one, okay, can you see shielding, okay, attached on the slab. So, and then this is mechanical and electrical also, the lamp, the fan, the wiring, the piping also we take as 0.3 kilonewton per meter square. Okay, we are not, let's say architect want the ceiling fan here. We are not calculate, okay, what is the weight of the ceiling fan, and then what is the exact position to become a point load. No. That's not a practical practice. Okay, it's impractical to use such way. So that's why we are using kilonewton per meter square, the units. Okay. Okay, so this is the, okay, the piping and then the M&E equipment. Okay, how about, so at the ground we only have ceramic tiles, and maybe we have services. Okay, we have ceramic tiles only. Okay, we don't have services and suspended shielding. So at the ground floor, based on my practice, I impose the load of 1.0 kilonewton per meter square on the slab. Okay, because here if we have okay, piping here, the piping will rest on the ground. Okay, except we have basement. The basement, if we have basement here, basement for car park, so the piping will rest on the slab. So we have to consider the services. But usually we never provide shielding at the car park of the basement. Okay. So upper floor, for upper floor we have ceramic tiles, services and suspended shielding. So the value is equal to 1.45 kilonewton per meter square. So I round up to 1.5 kilonewton per meter square. And for the flat roof, okay, this is the situations. So I make it as 1.0 kilonewton per meter square. Okay, for the roof with roof trusses, also I will consider 1.0 kilonewton per meter square. Let's say if you imagine that this is not a flat roof, but we have roof trusses here. Okay, the roof trusses also will support the shielding actually. Okay, it will support the roof materials. Okay, the pitch roof. Let's say the pitch roof here, and then at the bottom it will support the load from the ceiling and maybe from the wiring. Okay, and the value is I also use 1.0 kilonewton per meter square. Okay, may I ask you what is the meaning of 1 kilonewton per meter square? Do you understand what is the value of 1 kilonewton per meter square? Okay, it's okay. I will explain you. 1 kilonewton per meter square is means that for every 1 kilonewton, the value is ... Okay, let's say for this case, we have which one is simpler? Okay, this one. For this one, okay. Focus on the purple color of slab. Okay, so we have this here to here we have 4 meter run, and then here to here we have how many 6 meter run. Okay, so for every 1 kilonewton, for every 1 meter square, the load is the value of the in kilonewton. Let's say this is 4, so we divide by 4. We divide by by 4. Let's say this one, we divide 1. Okay, for 1 meter, and then 6 meter we divide by 6. Okay, so we have a total of 24 square of 1 meter. Okay, so this one, for every here, let's say this one. Okay, every small piece of the slab is equal to 1 meter square. Okay, so if the loading here, as I showed to you before, this one, let's say this at the ground floor, here let's say at the ground floor, the value is 1.0 kilonewton per meter square. So for our structure here, this is for ground floor. So for every 1 kilonewton per meter square, the loading is equal to, the permanent load is equal to 1.0 kilonewton. Okay, 1.0 kilonewton. Okay, where the value come from? It come from the tiles and ceramic floor. Okay, let's say if we have here 1 kilonewton meter, sorry, 1 meter square. So at the upper floor, the value is equal to 1.5 kilonewton per meter square. The value of 1.5 comes from this one. Okay, it comes from the finishing, okay, and then services, which is M&E, and then the suspended shielding. So I round up to 1.5 kilonewton per meter square. Okay, this is very important. You must be able to determine the loading later. Okay, so also here, this from the roof, usually I take let's say this one, just like in the slab. So for every 1 meter here is 1.0 kilonewton per meter square. Okay, when I know what is 1 kilonewton is approximately in kilogram. What is the value in kilogram? Can somebody tell me? 1 kilonewton in kilogram. 1.0 kilonewton is equal to how many newton?
1000 Newton.
Okay, good. 1000 newton equal to how many kilogram? Just divide by gravity.
Around 100.
Okay, let's say 100. Okay, 100 kilogram. Okay, so for every one, thank you. Sorry, alhamdulillah. So for every 1 meter square, the loading is around 100 kilogram. Okay, including the finishing, the shielding. Okay, let's say the shielding is for upper floor. Okay, 100 kilonewton is also still reasonable actually. Okay, so that's why if we have for live load we refer to this sorry, I need water. Okay, for live load we refer to this national annex, okay, to Eurocode. Do you have this document? Do you have this one? National annex to Eurocode 1, which is the actions on structures. Do you have it?
Yes, doctor.
Okay, good. Okay, if somebody don't have it, I will share later. Okay, don't worry. Okay, so you must refer to this as the action of variable load. So you have a few categories here: A, B, C. Okay, D. So for every category, we have the proposed load. Okay, let's say for if the okay, I ask you one question. If the area or the floor is heavy usage, let's say house, okay, a room in a house and a classroom, which one have heavier usage, heavier load?
Classroom.
the classroom, okay, because we have more people inside and we have more let's say a table and chair, okay, compared to the single private room. So that's why the loading here is okay. You can refer here office, but for our case is residential, so it is in category A. So you can refer this one. Okay, the units. Okay, let's say this one the bedrooms in hospital. Okay, hotels and motels, hospital wards, toilet area is in category A3. Okay, in category A3. Okay, you can refer to this table. Category A3 is okay, kilonewton per meter is 2.0. 2.0. So you can refer to here. Okay, so you can write down later here. You can write down. Let's say make simple. Okay, box. QK is equal to 2.0 kilonewton. 2.0 kilonewton per meter square. Okay, for every floor panel, okay, for every slab panel we have the imposed load or the imposed load or live load. Okay. Okay, so how about the bedroom? Let's say we refer to this document. Okay, the bedroom. What is the value of live load for bedroom? Can somebody tell me here? What is the category, subcategory?
A2.
A2, okay. This one, bedrooms and dormitories, okay. Except those in self-contained single-family dwelling units and in hotels and motels, okay. Ni balconies in single-family okay, sorry, balcony in hotel and motels, residential balcony. How about number one? Ni or a modular students accommodations unit with a secure door and comprising not more than six single bedrooms in an internal corridor, common areas. Okay, maybe A1 or A2. Okay, bedroom and dormitories. Okay, so we can check A1 and A2. What is the value? A1 and A2. Okay, similar value. So you don't have to worry. 1.5. So our loading here for bedroom. Okay, the QK is equal to 1.5. QK also 1.5. But here, for here we can consider as a corridor. Okay, because people will go, okay, come from the ground floor and then they will move here. You can consider as corridor. So what is the value of live load for corridor? Which category? Which category? Maybe this. Okay, areas without obstacles for moving people. Okay, or corridors here, C3. Okay, so you can look what is the value of C3, C31, 3.0. Okay, so here the loading here is 3.0. So how about the living space, the dining room? You can check from this table. Okay. Okay, communal areas including kitchens. Okay, is A1. Bedroom, balconies in single family dwelling units. A5, the balcony. What is the value for loading for balcony? A5 is 2.5. Okay. So here the balcony, for the balcony here the QK is 2.5 kilonewton per meter square. Also this one 2.5 kilonewton per meter square. Okay, I hope you can understand this lessons, okay, about the loading on the beam and loading on the slab. Okay, your task once you finish this Okay, once you finish this structure layout, okay, complete with column position, complete with beam position and beam label, complete with the, okay, let's say also slab. Okay, slab maybe we can have different size, different thickness. Let's say all thickness is 150 unless noted otherwise. Unless noted otherwise, let's say this one, since this is prayer room. So I want it to be, let's say 200 mm. So I just write down 200 mm and I make it a box here. This is how to how to declare that this slab is the thickness of this slab panel is equal to 200 mm. Okay, let's say here for the balcony this is very thick, so just write down 100 and make a box. The others, how about the rest? Okay, let's say this is also small. Let's say this is also 100. This is also 100. Okay, how about the rest? The rest is equal to 150 mm. There will be a note later. Okay, let's say notes of all slab thickness. Okay, all slab thickness shall be 150 mm unless noted otherwise. U and O. Okay. So dia tak perlulah tulis setiap ni berapa tebal dia akan jadi serabut you punya drawing kalau nak tulis semua slab thickness. Orang tak buat macam tu. So orang buat yang lain semua masuk je kat baca notes. Yang lain semua tebal ni adalah 150 kecuali yang noted otherwise kat sini. Okey, semua faham Okey, kita ada sekejap lagi kelas untuk sebelum kita tamatkan. So you punya job today is to do okay, saya buka yang lain lah. Saya buka yang lain, sorry. This project. Okay, structure layout. Okay, I open a new one. Okay, your task. Okay, after completing the structural layout is I want you to present a free body diagram. Okay, one member will propose 2 beams. Okay, one member 2 beams. So if you have 4 members, so the total beam shall be 8 different beams. Okay. Okay, so what I want you to do is I want to do the free body diagram which show the source of loading. Okay, so you can use, let's say this is the example, okay, from last semester I used. Okay, this is the span and then what is the loading. Okay, because I want you to clear. Okay, I don't want you to, terlepas pandang, okay, daripada mana loading tu datang. Okay, so contoh example is what we are going to do is let's say we are going to do for beam. Which one you want me to show you? Okay, the simplest one. Okay, the simplest one. Let's say beam number. Okay, FB12. Okay, FB12. Okay, FB12. I will. Okay, this is FB12. So I show you FB number 12. So you can. What you are going to do is you must okay. Just do. Okay, this is the. Let's say this is the beam. Okay, and then the support here. Okay, this is the support. Okay, you can use different color. Okay, you want to sketch also, you can sketch. Okay, this is the support, and this is also another support. Okay, okay, one span. Okay, you can detect. Okay, the support here is supported by the beam and not the column. So what is the beam that support it? Okay, the first span. Okay, let's say this one. Okay, we make So the grid line is D1. Okay, this one D1 stroke 3. For here D1 stroke 3 is the support, and then another one is D1 stroke 1. Okay, the support is D1 stroke 1. So D1 stroke 3, what is the support? The support is this one, FB3. FB3 will support it. So make it FB3, and then FB1 will also become the support. So write down as FB1. Okay. So what is the source of loading? The source of loading that you can have this table. Okay, what is the okay, let's say this is unavailable because we only have one span. Okay, we only have one span. This is okay, single span. So the source of loading, okay, this the loading, let's say the loading is similar, okay, equal, okay, or uniformly distributed. So span number 1, which is D1 stroke 1, D1 stroke 3 to D1 stroke 1. Okay, what is loading number 1 that you expect will act on this beam? FB12. What is the loading? Of course, the first is the safe weight of the beam. Okay, so you just type the safe weight, and then loading number 2 is the brick wall. Okay, let's say this is the balcony. So the brick wall is only 1.2 meter height. Okay, the brick wall here is 1.2 meter height of brick wall. Okay, can you imagine the balcony here? This is the side view. Okay, this is the balcony, and this is this one. Okay, this is the cantilever part of the beam, and then this is column. So the height of the brick wall usually around 4 feet or 1.2 meter. Okay, so the brick wall, okay, 1.2 meter, 1.2 meter height brick wall. This is GK. GK stand for permanent load, and then loading. Okay, you can label your slab. Okay, let's say this one. Okay, this is slab number 1, and then slab number 2 S2, slab number 3 S3, slab number 4 S4, slab number 5, and then slab number 6. Okay, so slab number 6 will come, so slab S6 as the QK. Okay, do you agree with me? Slab number 6 will go to FB12. Okay, half of the slab will go to FB number 12 as the dead load as GK, and then loading number 4 is also comes from slab number 6. However, this time the type of loading is QK. Okay, so this is all the loading that might acting on the FB12. Okay, can you do for your own key plan? Okay, you can watch this video later. I believe you can do it. Okay, let's say this okay, we make it which the more complicated. Okay, let's say FB14 will become similar. Okay. Which beam you want to try? Okay, how about GB1? Okay, how about GB1? Okay, so we try the GB1. Okay, GB1. So you okay try just okay. The number of span is we have total 4. Oh, sorry. We have 4 spans. Okay. So you just do it. You can use your hand sketch if you want. Okay. Okay. So this is okay. Just approximately. Don't need to be so. I mean, perfect. Okay. So this one. Okay. And also this one. Okay. So what is the support now? May I know what is the support? The support is A1, A/1, okay, and the type is you just mark it as C. C stand for column, means the support is column, and then B/1, the support also is column. C/1, the support also is a column. D/1, the support is also a column. Okay, and then you can have this table again. Just copy and then make it here. Okay, maybe I can use a smaller font. Okay, because we have three span and sorry. Insert column right. Okay, good. So we have A. This is how many span we have? We have 3 spans. Span number 1, span number 2, and span number 3. So what we have here is span number 1. Okay, the loading number 1 is safe weight. Okay, span number 1 is A1, A/1, 2, B/1, and then span number 2 is B/1, 2, C/1, and then span number 3 is C/1, 2, D/1. Okay. Okay, I hope you can see this one. And then of course every span have its own safe weight. Okay, and then okay, do we have the brick wall here on this beam?
Yes.
Okay, let's say okay the height of the brick wall. Okay, you can determine later. So we have the load number 2 is the brick wall. Okay, and then what we have on brick wall, and then what we have on span number 1. Let's say we have this is our slab. Slab number 1, slab number 2, slab number 3, slab number 4, slab number 5. Okay. So we have loading from slab number 1 as a GK, also slab number 1 as a QK. And for span number 2, we have which slab will contribute to the loading? Slab number?
3.
Slab number 3. Okay, good. Slab number 3, also slab number 3. And the shape of the loading is what? Should be what? because you know right, the shape either triangular or trapezoid. Okay, you see this one. Let's see this one. Okay, the shape is trapezoid. So you can how to determine the value. You can refer to this notes later. Okay, what is the value will go to the beam from the slab. Okay, either the trapezoidal or triangular. So if the load is, let's say for slab number 1 is UDL, so you can mark it as UDL. Okay, and then this one is trapezoid, TZ trapezoid. This is also TZ trapezoid. And how about slab number, sorry. Okay, how about span number 3? How about span number 3? Which slab will contribute?
5.
Okay, good. Slab number 5. Okay, slab number 5 will contribute to the S. Okay, what? How about the shape trapezoid or 6? This is 6 meter. Here to here is 6 meter. 6.5. So it almost lebih kurang lah. Still TZ trapezoidal. Okay, the value is okay. You can calculate later. I just want you to detect, okay, or to understand what is the loading that will come. Okay, so if you do for beam GB3, so you might have a source from let's say this is no brick wall here. So if the span number 2 no brick wall, so you just okay no, just write down no brick wall. Let's say for GB number 2, GB number 3, no brick wall here because people can go through here, and this is for living room. Also no brick wall here, no brick wall here. So just write down no brick wall, and then if you have 2 slabs, let's say slab number 3 and also slab number 5. This is 6. This is number 7. So you write down. Just write down. Let's say okay, loading 3 and loading 4. It's okay. You don't have to calculate the value. I just want you to detect what is the loading that might come. Okay, this is a skill. Okay, so let's say this one I'm doing for, let's say I'm doing for GB2. So the loading will come for slab number 2. Let's say it comes from number 2 as the also trapezoid. Okay, the shape also trapezoidal. Okay, this one also trapezoid. Okay, slide number. Okay, slide number 2, slide number 7 also trapezoid. But for span number 2 here, we have slab number 6, which is trapezoid, and then we have slab number 8. Okay, slab number 8, we have triangular. Okay, alhamdulillah. So I hope. So we have slab number 6. Let's say this one slab number 6 now, trapezoid, and then slab number 8 is triangular. So the TR, okay, QK, and then the TR triangular GK. Okay, and then span number 3 here, and then you have span number 4. Okay, can you do it and then submit also inside your report later? Okay, I want everybody to do at least for 2 beams. If you want to do it more, you can do it. So inside your report later, your progress report, you have to submit by week number, maybe by the end of week number 5. I believe you can submit by the end of week number 5. You have to submit the architect, the architect layout. Okay, you don't have to provide me the front view, the side view, and so on. It's okay. architect, I just want the layout. Okay, architect key plan layout, and then the structural layout. And then you must also include the pre-body diagram of 8 beams. Okay, so every member provide two, at least two. So let's say you want to do this. Okay, for this for beam number, let's say GB4, you have point load. Okay, let's say you have point load from GB. Okay, let's say for this span, for span 5A to 4A, you have point load from GB 13. So you just okay, add another row. Okay, and then loading, let's say loading number 5 here. Let's say point load. Okay, because the GB13 rests on GB4, so it will become a point load later. So let's say point load from GB13 GK, and so load number 6, just insert okay here. Load number 6 also. Okay, let's say straight add 4A. Let's say this is A, this is 4A. 4A stroke burst. 4A stroke 4A stroke B. Okay, B stroke 4A. Okay, at B stroke 4A. So we know the position of the point load, and then you do the sketching. Let's say you have point load here. So this, okay, this is the point load. Let's say for GB4. Okay, and this one is QK. Okay, I believe you can do this one inside your report. Okay, so you must be able to detect, okay, which one is the how many span the beam have, what is the support of the beam, how many span, and what is the support, and what is the loading that will act on every span. Okay, I believe you can do it. So okay, so thank you very much for watching, and I hope you enjoy to learn these lessons. Okay.